Welcome back guys. Today we are going to study about the volume and surface area of composite shapes. Before discussing the volume and surface area of composite shapes, let us first recap the volume and surface area of basic shapes. For the cube, the volume is equal to length into length into length or length cube. And its surface area would be the sum of the areas of its 6 surfaces. The area of one surface is equal to length into length. For the cuboid, which has unequal sides, the volume would be length into width into height, and its surface area would be twice the sum of the surface area of 3 different sides. The sphere having radius r would have a volume of 4 by 3 into pi into r cube, and its surface area is 4 pi r square. For cylinder, we have the formula of volume as base area into height, which is pi r square into h, and for the surface area it is 2 pi r whole multiplied by base radius into height. A cone with base radius r, height h and slant height l, its volume would be 1 by 3 into pi into r square into h, and its surface area would be pi r into r plus l. For the triangular prism, the volume would be half into selected sides and its perpendicular height multiplied by the length of the prism. And its surface area would be side into perpendicular height plus length into sum of all the sides of the triangle. Let's see what is a composite shape. A composite shape is made up of more than one basic geometrical shape. In this shape, the cone and the cylinder is joined up to make a composite shape, while over here, 2 cuboids are joined to make up a composite shape. Now let's see what is a volume and volume of a composite shape. Volume tells us how much the space the object has occupied. In the composite shape, the volume is the sum of the basic geometrical shape the composite shape is made up of. To find the composite shape volume, we will add the volume of a cone and the cylinder, while over here we will add the volume of 2 cuboids to get the volume of the composite shape. As discussed, this shape is made up of a cone and a cylinder, so the volume of a cone is 1 by 3 pi into base radius square into height, while for the cylinder the volume would be pi into base radius square into height. For the volume of shape number 2, which is made up of 2 cuboids, we will calculate the volume of each cuboid and then sum them up. For the surface area of composite shape, we will take into account all the exposed surfaces, and we would not include any covered surface. In this diagram, we can see that the circular base of the cone and the top circular base of the cylinder both are covered by joining each other. Therefore, we will take into account only the curved surface area of the cone, the base area of the cylinder, and the circular curved surface area of the cylinder for calculating the surface area of the composite shape. Mathematically, the curved area of the cone would be pi into base radius into slant height, while the exposed surface area of the cylinder would be 2 pi into base radius into height plus pi into base radius square of the cylinder. For the surface area of the second shape, which comprises of 2 cuboids, we will take the surface area of the exposed surfaces of the 2 cuboids. Here we can see that the base cuboid is having a covered surface due to the placement of the top cuboid. So this area would not be taken into account while calculating the surface area of the base cuboid. Similarly, while calculating the surface area of the top cuboid, we will not calculate or take into account the bottom surface as it is placed on the top of the base cuboid. To find out the surface area of top cuboid, we will calculate the areas of side surfaces, which is length into height. Similarly, we also calculate the front and back surface area of cuboid by multiplying breadth into height. After finding them, we multiply these two areas with 2, as we have pair of these surfaces. Lastly, the top surface area is also calculated by length into breadth. For the bottom cuboid, we use the same logic of exposed surfaces. Here we have two side surfaces of length into height and two surfaces of breadth into height. For bottom layer, we calculate it by multiplying length into breadth. The top surface is calculated for the exposed area only, which is by subtracting the covered area, which is shaded into brown, from length into breadth. The dimension of shaded area is dependent on the top cuboid lying on the top surface of base cuboid. Here, it is imperative to note that the volume of composite shape is not always found by adding the volume of basic shapes from which the composite shape is made up of. In this shape, we see that the volume of the composite shape is calculated by subtracting the volume of the semi-cylinder from the volume of the cuboid. The total surface area is the sum of curved surface of semi-cylinder and the 5 faces of cuboid. In shape 2, the volume of the composite material is equal to the volume of the cylinder minus the volume of the semi-sphere inside it. The surface area of this shape is equal to the surface area of semi-sphere and the surface area of cylinder minus the area of circular region of semi-sphere. Let's do some examples to gain the required confidence. Shown on the screen is the composite shape made up of two cuboids with dimensions as shown. For the volume of the shape, we would add up the volume of both the cuboids. So for the volume of the base cuboid, which is length into breadth into height, we will put in the values and it comes out to be 8 into 6 into 5, which is calculated to be 240 cubic units. For the volume of the top cuboid, it would be 6 into 4 into 3 or 72 unit cube. So the total volume of the shape would be 240 plus 72, which comes out to be 312 unit cube. For the surface area of the shape, we have to calculate the areas of all the exposed surfaces of two cuboids. To calculate the surface area of base cuboid, we have to take the area of side faces, the front, back, bottom and the exposed top surface. Therefore, for the side surface and the back and front surface, we will take into account 8 into 5 plus 6 into 5 whole multiplied by 2. For the bottom surface, we multiply 8 into 6. Now for the top surface, we will take the top view of this shape. The gray area is the covered area by the top cuboid on the base cuboid. Now, as we can see that there are two regions, one in pink and one in green, which is exposed. So for both the surfaces, we take 8 into 1 and 4 into 1 multiplied by 2. Adding all them up, we get 140 plus 48 plus 22, which comes out to be 212 unit square. For the top cuboid, we will take the two side faces, front and the back face, and the top surface. Remember, the bottom surface is covered by base cuboid, therefore it will not be added while calculating the surface area of the top cuboid. So putting the values of each length in the formula, we get a total of 84 unit squares of surface area. To get the total surface area of the composite shape, we will add the surface area of the base cuboid and the top cuboid, and this comes out to be 296 unit squares. Let's work out another example and find the volume and surface area of the composite shape as shown on the screen. As we have studied, the volume of the composite shape over here is the volume of the cone added with the volume of the cylinder. Getting back to the basics, volume of the cone is equal to 1 by 3 into base area into height. So by putting the value of base radius as 4 and the height as 5, we get the volume of the cone as 335.103. For the volume of the cylinder, which is equal to the base area into height, you put the value of height as 8 and the base radius as 4. And by calculating, we get the total volume of the cylinder as 1608.49. To get the total volume of the composite shape, we will add the volume of the cone and the volume of the cylinder. This comes out to be 1943.593 unit cube. Now to calculate the surface area of the composite shape, we will take into account the exposed surface area of the cone and the cylinder. The exposed area of this cone is the area of the curved surface of the cone only, which is equal to pi into base radius into slant height. Here, since the slant height is not given, so we will calculate the slant height by taking the square of the base radius and the height of the cone and taking whole under root of that through the help of Pythagoras theorem. The base radius is 4, and by plugging in the value we get the surface area of the curved surface of the cone as 80.46. For surface area of the cylinder, we will take into account the curved surface area of the cylinder and the base area of the circular shape. By plugging in the value, we get the surface area of the cylinder as 251.33, and the total surface area of the composite shape will come out to be 80.46 plus 251.33 is equal to 331.79 unit square. Here we have another example to find the surface area and volume of a composite shape. Here you can see that the volume of the hemisphere is scooped out from the cylinder. Therefore, the volume of the composite shape would be equal to the volume of the cylinder minus the volume of the hemisphere. Since the volume of the cylinder is base area into height, we get the volume of the cylinder as 1005.31. For the volume of the hemisphere, we have the radius 2, therefore putting in the values, we get the volume as 25.13. Subtracting it from the volume of the cylinder, we get the total volume as 980.18 unit cube. For the surface area of the composite shape, we will take into account the surface area of the cylinder and subtract the surface area of the gray circle on the top of the cylinder. However, we will add the surface area of the hemisphere. As we know that the surface area of the cylinder is 2 pi base radius multiplied by height of the cylinder, while the surface area of the circle is pi r square and that of the hemisphere is 2 pi r square. Plugging in the value of capital R, small r and h, we get the surface area of the composite shape as 238.762 unit square. So in the end, it is all about the volume and surface area of the basic shapes of which the composite shape is made up of. In some cases, we will add up the volume of the basic shapes to get the volume of the composite shapes. However, in some cases, we have to subtract the volume of the basic shapes out of the composite shape. For surface area, we have to take into account all the exposed surfaces. I thank you all, and please like and subscribe for more educational videos of mathematics.